Hello students, welcome to Learner's Planet. So students, this will be our fourth problem solving session for chemistry paper of AIEEE of 2010. So there are, I suppose, 6 or 7 questions remaining of this paper. We will solve it in this session. So let's start our solving session, students. Now this is a question over here that at 25 degrees centigrade, the solubility product of magnesium hydroxide is 1 into 10 to the power minus 11. So, what is the formula for solubility product? Say the solubility, let's take out the solubility product of magnesium hydroxide. So, Ksp will be the concentration of magnesium and this is hydroxide. If I take this concentration in terms of solubility, it would be Ksp is equal to S into S square, right? So what is S? S is the molar concentration of the substance of that particular ion in its saturated solution, right? Now here, this I didn't put the signs over here, OH and this is minus. Now, at which pH will Mg2 plus ions start precipitating in the form of magnesium hydroxide from a solution of 0.01 molar Mg2 plus ions. Now we have got the concentration of Mg2 plus ions over here. See, what is it? 0.001 molar Mg2 plus ions, right? So what is the solubility product given to us? It is 10 to the power minus 11 divided by 0.001. We are provided with this many ions. So how much of hydroxyl ion is required to precipitate? What is our question? Our question is how much of OH ions is required, or what should be the concentration of OH ions required or in the solution to precipitate magnesium ions as magnesium hydroxide, right? So from here, so this is equal to OH square. Now what will be OH minus will be equal to square root of 10 to the power, how much it would be? By 8, right? Or OH ion concentration is equal to 10 to the power 4, right? Or your POH will be equal to how much? 4. This is minus, this is again minus, that is why it is coming out to be 4. What is pH and POH? pH and POH is the minus or negative log of H ion concentration, right? So this is 4. So what will be the pH, students? pH plus POH is equal to 14. So what will be the pH? pH should be 10. Right? So this question has been slightly twisted. despite of asking how much hydroxyl or what should be the concentration of hydroxyl ions so that your magnesium ions precipitate, it is asking what should be the pH of the solution, right? So this is slightly twisted one. That's it. And it's a simple question. See, in 2010 there were 2 questions from your solubility product, one from equilibrium topic. So it covered all about 3 questions. Out of 30, there were 3 questions of ionic equilibrium topic. One, this conjugate acid-base pair was also the question. So 4 questions. Now let's take up the next question, students. Percentage of free space in cubic closed packed structure and in body centered packed structures are respectively. So what are it's asking free space. You know the packing fraction? The packing fraction of different structures. See, the packing fraction of cubic closed packed structure is 74%, right? The packing fraction what it is? It is the percentage of volume occupied. Right? For cubic close packed structure is how much? It is 74%, and that of your BCC, that is body centered cubic close packed, is 68%. So what will be the percentage of free space? Is equal to what? It is 100 minus 74, and it is giving 26% in CCP. And percentage of free space in BCC would be 100 minus how much? 68, and that is equal to 32%, right? So what should be our answer? 26% and 32%. It's a very, very easy question from solid state. It's just that you should know the figures, that's it. Now let's take up our next question, students. Yeah. Out of the following, the alkene that exhibits optical isomerism is? For that, you need to draw the structure. Now, for a molecule to show optical isomerism, what is required? The required conditions are: the first, that they should have a chiral carbon, what is a chiral carbon? A carbon to which 4 different groups are bonded. Like, say, there is an OH group, it can be hydrogen, there is CH3, and there can be COOH. So this is a chiral carbon. And second, that this should not have the molecule should be asymmetrical. Asymmetric. That is, it should not have any type of symmetry, right? That is the plane of symmetry or the axis of symmetry or the point of symmetry, nothing should be there. Now let's analyze all these structures. See, it's 3-methyl-2-pentene, so it should be 1, 2, 3, 4, 5. So there should be 3-methyl. There is a methyl group over here. Now, is this molecule asymmetric? Is this molecule having a carbon atom which is bonded to two different groups? No, it is not, right? So this is one group, which is again what? Ethyl group, and this is another group. So that is the same group, C2, So this is not an optical isomer. Now let's take up the next option. It is 4-methyl-1-pentene. It means it is H2C double bond HC CH and CH2CH4-methyl. So it is 1, 2, 3, 4 and CH3. 1-pentene, right? Is it asymmetrical? No. This carbon is bonded to 2CH3. So that option is also obsolete. Now we have got our third thing. What is it? It is 3-methyl-1-pentene. So that is H2C double bond CH CH3 3-methyl-1-pentene. That is, here we have got CH2 CH3. See, this is an ethyl group. How many? Let's take out the groups. This is C2H5. This is what? This is C2H2, C2H4, that is ethene, right? On one side it is bonded to an ethyl group, on the other side it is bonded to an ethene. See here, this was C2H5 and here also it was C2H5, right? On one side it is bonded to ethene, on one it is methyl, and other is this hydrogen. So what is this carbon? So here this carbon is the chiral carbon, right? So this is the chiral carbon, okay, and it doesn't have any plane of or axis of symmetry. So what is our answer? We have got, it is one option correct type of a question, so we can mark this answer as correct. Right? Now let's check out for this also. 2-methyl-2-pentene. Let's see if this is right. It is 2-methyl-2-pentene. CH3 CH3 double bond C CH2 3. This is CH2 and this is CH3, right? So is there any chiral carbon? No. There are two methyl groups over here. So what is the right answer over here? 3-methyl-1-pentene. So students, always remember that this thing, an optical isomer should have one chiral carbon atom. That is, there should be one carbon which is bonded to 4 different groups, right? Now let's take apart this. So this was your question from General Organic Chemistry, GOC. Let's take up the next question, students.